Trying to separate all three barriers. We're trying to separate the WRB, that's your water resistant barrier. Also, you're going to separate your thermal barriers, and then we're separating the air barrier. Back in the day, we put them all in one, like, oh, spray can, good to go. All right, so what we're trying to do is we're trying to separate all three barriers. We're trying to separate the WRB, which is going to be the surface of your zip panels here. That's your water resistant barrier. Also, you're going to separate your thermal barriers, which is your thermal mass. Now there's mass inside the wall, and then there's also mass behind the zip R. And then we're separating the air barrier. Back in the day, we put them all in one, like, oh, spray can, good to go. Well, now on high efficiency building, we're separating them all, and I need you to identify which ones they are. So the WRB is going to be the nail fin integrating the window into the WRB. So we seal that, and then we're going to use flashing tape. So that's one full system. Water runs down. You're going to do a shiplap style where you start on the sides and then you overlap the top. A lot of this we're just using regular things like gravity, not active systems, just gravity to help you out. So if there actually ever is water on this surface, because of your skip caulking, capillary action is going to pull this water down with gravity. Now, even if you do have a problem, your house fixed it for you. Okay, so these are just things you're thinking ahead on of if it comes far enough in, this is cedar, that's fine. Now, the reason, what's odd about really high efficiency building is you got to think about the air barrier. This is the weird one. Remember how you were saying we skip caulk here? Well, that means air can come up through here, right? We start depressurizing. There's different differential pressures on the outside and inside. So you're going to have air drive. So what we're going to try to do is we're bringing the air barrier from the outside surface. We're bringing it through the opening so that allows the water to weep through. And what we're actually going to do is we're going to caulk the inside of the window to this surface now. So you're thinking 3D. So now the air barrier is completely continuous. It comes all the way to the inside. We caulk it to the inside of the window. That allows when water's on this side of it, it comes out. So, I mean, if you're trying to trap air, you're also trapping water. That's why we brought the air barrier inside, which is why they taped it all the way around. So it's belt and suspenders and like everything. This is solid install. So what I'm doing is I'm checking the opening ahead of time to give me an idea when I put this window in, because the window needs to be square, plumb, true, and level. So it needs to be all the things. You're also measuring corner to corner. These guys are going to show you to see if you rack the window or not.
The window, they're trying to achieve that this window is level, plumb, and then square, right? That's what he was trying to achieve out there. And so we did that from the inside. So you were outside, but while he was out there, we Doug shimmed this window to try and achieve that. So that's what these what you were looking at before, these shims, and then he has two sizes in there. He has a blue and a red, and that allows this window to sit level. Now, if this window weren't square, then we'd have to push it from the sides. I mean, there are a variety of ways of doing it, but one way to do it is to push it from the sides.
So if your RO's a little off, I don't care. The window needs to be square, plumb, and level. So don't worry about, oh, it's 1 inch here and it's only a 1/4 inch there. That's fine. That's why we have shims, and you want your window to be sitting just completely independent. And the reason we take so much time and should be taking more time on windows is because it's a transition point. Transition points are where we get water and air infiltration, where things rot. I mean, this is where you get mold growing in walls. So you want to take that time to make sure your transitions are correct, because it's very easy, like siding and putting up OSB, to just run flat walls. It's really easy, it's really quick, it's relatively efficient. But once you start putting penetrations, that's where you have leak points and where you start having problems. So there's a lot of different technology and stuff you can use. This is something where if I need the window to go up or to go to the left or to go to the right, you can put in bags. You can also use, if you need a little more force, these are 500 pounds of force, where I can just stick it into the opening and I can jack it over one way or another. So when I'm looking at this, they're actually pretty good up there. That's why I had them go 4 squares. It's a rough set. So they put a screw in that corner, that corner, that corner, and that corner. So right now it's not going to fall out. And right now I'm doing adjustments. So what I noticed is that if you look at the level, the RO isn't quite level, but the window is. So that's why you have 4 shims over here. You have 2 shims over there. I mean, I don't need to explain shimming to you. So what I'm noticing here is that our window, it opens great, but it doesn't lock smooth. I mean, I can force it. Well, now we gotta start thinking about why, and that's because this is actually, all the hardware is in what's called the shipping mode. So I'm gonna go get my tool and I'll show you the adjustment points in this window. And the reason we're doing it now is that before you tape it off and go through all that hassle, if I need to reshim something or something's wrong, right now is a perfect time to do it. Yep, so looks like a fancy tool. It's just a hex head. That's all it is. Don't let Europeans wow you with nothing. This is just a hex head, but it's bent for certain ways to make our life easier. So, may have to take turns to come in and see it, but I'm going to put my adjustment tool in an adjustment point. So I'm going to let you see where it is and how it works. So what I'm doing right now, I'm putting my tool in this adjustment. It's basically right at the bottom hinge. There's 2 collars, sit on each other. It carries the whole weight of this window right on this point. There's a screw that goes through it all. Right now, it's collar on collar. So what I do is so now I take 2 turns and now I lifted the sash up. The reason I do that while we install is because all that, instead of being bushing on bushing, now it's on a point, and now this thing actually moves like a regular door, not a bank vault. So if you look at that adjustment point, that's where it is there. And there are multiple adjustment points throughout the window, but this is the main one that I like to use right away. I like to get it off the bushing. I like to get all the hardware up in the right spot. And then before we screw and tape off, now I know. I'm not maxing out my adjustments. If I do that, I screw myself as a service tech later on in life. I need to have room to go up and down later on. So I don't know if you can see it. It's this way up, this way down. So what I did is I just adjusted that all the way up. There's also another adjustment point put right here. You can look at that one. This one actually moves the adjustment, moves this sash this way. So if you think of it in the opening, it moves the bottom like this. And then there's another adjustment point up here, which shortens or lengthens the arm. Okay? So, no. So if we think about this, when we get this in the opening here, if I put this in here, oh, it's like butter now. Cool.
Everybody has a pencil.
Except for me. All right. So what I do is just a little trick that we use as service techs is, where is the window in the opening? So now those marks show me that this opening is about, it's a little over 3/8, and then over here we're having, it is 3/8. So right now it's centered in the opening. That just tells me, that's information. So you see how I marked the bottom of the sash here and the top of the sash here? I can move this sash up and down in that opening. This weather strip can handle that too, so it doesn't matter. But just, is the opening weird? Is the situation weird? Also need all of these little points to line up with these hooks and this bottom one too. A common thing that happens is with all this weight, a lot of times what happens is the weight tries to push down and you'll hear clicking right here. So we're at a point now where I can kind of feel it. I know what it's supposed to be like, but there are adjustment points to even, you see the 1, 2, 3 layers of weather stripping in here? That's what makes the air infiltration numbers on this window so good. So what I can do is, if we do our depressurization and a thermal IR, and all of a sudden, like, Doug, we're getting a lot of air coming right through here at 50 pascals, which is what the number is when we're depressurizing. Okay, so what I can do is I can actually take the adjustment tool and I can stick it into these points, and I can actually increase compression or decrease compression. So the more compression I have, the harder it is to work. That's fine, but there's usability and then there's also efficiency. So watch this point right here. This goes all the way around the window. There's a safety trigger here. This is, now we're getting into the weeds, but if you watch this, when I move it, okay? So that's a different mechanism than when I close it. This is closed and locked. This is open this way. And then if I pull the handle all the way up, now all of a sudden the top creeps in. So that's venting. What I see a lot of times right away is that the weather stripping is just cold and tight. So it's okay. I can always come back later if it actually is a problem. But sometimes going for perfection, you mess more things up. What I'm going for is operability and are we passing tests. So I can go around here. I've already been feeling and moving this stuff around. So I've done it long enough where I can just do it while we're talking. But to me, this feels tight. It feels operable. And probably most likely over time that these weather strips are going to start kind of be worked into themselves and the operability will get better. If not, when I come back, what can I do? I can adjust the compression over here like I told you. So right now, I know we want to go for testing. I'm going to keep it tight because I want a tighter test. I'm not cheating. That's my capability of making it tight or loose. Does the customer that ultimately buys this house, well, they're going to want them looser or tighter? It's just operability or efficiency. You can't have both. That's why double hung windows are very inefficient. They have slider seals. If they got really, really tight, then you couldn't operate them. They wouldn't move. Yeah. That's why casement windows or tilt and turn windows where you close and lock, clamping seals, that's why they're more efficient.
Possibly a little lower, so you know you gotta get over it.
Yeah, we do our four corners.
Right about there. Yeah.